Okay, now it's time to test the whole scenario. First, we will log in to the Bastion host of the application VPC. The key pair needed to log in is on my local machine, so I can use it to log in. But the key needed to log in to the application server is not available in the application VPC. Therefore, we will need to copy the key from my local machine to the application VPC. Similarly, we will log in to the network appliance to monitor traffic. To do this, we will first log into the host bastion of the security VPC. But that VPC also does not have the key needed to log into the network appliance, so we will have to do the same thing again. We will need to copy the key from my local machine to the security VPC and then use it to log into the network appliance. So, let's get started. Okay, here I am in the terminal in the directory where I have the key pair. First, I'll use the pwd command to verify the existing directory. I'm in the downloads folder, which is where I have my key pair. Now, if you are using a new key pair, you need to change its permissions. Otherwise, you will not be able to log into the instance. The command to change the permissions is chmod 400, and then the name of the key pair, in this case ec2-ohio.pim. The next step is to copy the key pair to the host bastion of the application VPC. For that, we will use the command -cp-i, followed by the key pair, in this case ec2-ohio.pim. This is the name of my key pair. Next, the name of the file you want to copy, which is also ec2-ohio.pim. Next, the username of the Bastion host, which is ec2-user for the Amazon Linux AMI, arroba, the public IP address of the Bastion host. To get this, we will need to go back to the AWS console. I select the EC2 application Bastion, copy the public IP, go back to the terminal, and paste it here, followed by a colon, and then the path where you want to copy the file. In this case, it would be /home/ec2-user, which is the home location of the EC2 user. Press Enter, confirm with a yes. And the key file has been copied to the application's VPC Bastion host. Now, we are ready to log in. So, the command is ssh ec2-user, arroba, the public IP address that we copied earlier, followed by -i, followed by the name of the key file, ec2-ohio.pim, press Enter. And now, we are logged into the application VPC Bastion host. From here, we can log into the application server. But before we do that, let's verify that we have the key pair we just copied. We will use the pwd command to verify that we are in the correct location. Indeed, we are. And we will use the command ls, and we can see the same file name that we copied. Now, let's log into the application server using the command ssh ec2-user, arroba, and this time we need the private IP address of the application server, because both the Bastion host and the application server are in the same VPC. So, they will communicate using private IP addresses. So, back to the EC2 console. I select the application server, copy the private IP address, go back to the terminal, and paste it here, followed by the key pair name, ec2-ohio.pim, confirm with a yes. And we are logged into the application server. Now, we must do exactly the same for the security VPC Bastion host. So, I'll open a new terminal tab, and I'll start by typing scp-i ec2-ohio.pim, again ec2-ohio.pim ec2-user, arroba, And we need to copy here the public IP of the security VPC Bastion host. So I go to AWS, select the EC2 security Bastion, copy the public IP, go back to the terminal, paste it here, followed by a :home/ec2-user, and press enter, confirm with a yes. And the key pair has been copied to the security VPC Bastion host. Now we are ready to log in. The command is ssh ec2-user arroba, the public IP address we copied earlier, followed by -i, followed by the name of the key pair ec2-ohio.pem, press enter. And we are logged into the security VPC Bastion host. From here, we must reach the network appliance. For that, we will write ssh ec2-user arroba, the private IP address of the network appliance. We paste it here, followed by -i and the name of the key pair ec2-ohio.pem. I press enter. We confirm. And we are now logged into the network appliance. Now, we're ready to generate some outbound traffic from the application server, and we should see it reach the network appliance. So, let's go back to the first terminal, and I'll clear my screen. And let's use the ping command to generate outbound ICMP traffic. I'm going to ping 8.8.8.8 and press enter. And we should see this traffic arrive at the network appliance for inspection. But as you can see, we get no response, and we don't expect it, because the network appliance we are using is an EC2 instance, not a real network appliance. So, it doesn't know how to handle the packets coming from the load balancer using the Geneva protocol. But we know that we have configured this correctly. So, let's go back to the other terminal where we've got the network appliance logged in. I'll clean this up. And here, we'll use the TCP dump utility to capture the live traffic coming into the interface. For that, let's use the command ifconfig to verify the interface name. This is the name of the interface on which we will use the TCP dump utility. I will copy it and clear the screen again. The command is sudo TCP dump, followed by -i, and paste here the name of the interface I copied, followed by -n, which will prevent IP addresses from being converted to domain names. And then we will use pipe, followed by grep, to match the packets containing the required string, in this case, the IP address 8.8.8.8 that the application server is trying to ping. I hit enter. And we can see some results. I'm going to press Ctrl+C to stop capturing packets. And here we can see that the traffic is coming from the private IP address of the application server. The traffic is bound this IP and is using ICMP protocol, and this packet is forwarded using Geneva protocol. Therefore, the network appliance inspects any internet traffic coming from the application server. Now let's try to generate traffic in the opposite direction. That is, ping the application server from the internet and see if that traffic reaches the network appliance for inspection. First, we will stop the thing we started earlier. Now, let's open another terminal where we are not logging to any appliance or Bastion host. And from here, let's try to ping the application server. So, I go back to AWS, copy the public IP of the application server, go back to the terminal, and type ping, paste the IP. We don't get any response. That's fine. Let's go back to the network appliance and see if we can capture this traffic. First, I'll clear my screen. And we'll use the same command but replacing the latter with the private IP address of the application server. We must match the private IP and not the public IP. This is because the Internet Gateway will translate public IP addresses to private IP addresses for incoming traffic. So, let's go back to the AWS console. Copy the private IP address of the application server. Back to the terminal. Paste it here, and press Enter. And here we can see some traffic. I'm going to press Ctrl-C to finish. And we can see that the ICMP traffic is coming from my public IP address, bound to the private IP address of the application server. The public IP address of the application server is being translated to the private IP address that the network appliance sees, and this traffic is forwarded using the Geneva protocol. So, with this demonstration, we can see that the gateway load balancer was well configured. It was a bit complex, but I hope you enjoyed it as much as I did showing it to you. Remember to remove your configuration as there are many components that we have implemented. Start by removing the additional routes you configured pointing to the gateway load balancer endpoint. Then, remove the endpoint and the endpoint service. Next, remove the load balancer and the target group. Then, terminate your EC2 instances, and finally, remove the VPCs, subnets, routing tables, and internet gateways. In the meantime, see you next time.